For over a century, the legendary tales that have surrounded our great British airfields have inspired generations of people, including me, which is why I am on a personal mission to cross the UK to visit some of our most important airfields, to understand not just about their contribution to our past, but importantly, how many of them have helped define our future. From the UK's first flight, through to groundbreaking innovations such as carbon fibre and the jet engine, and the extraordinary effort spent on preserving our aviation heritage. Join me as I explore the story of the airfields that have helped shape Britain and the world. I'm here in Farnborough, the birthplace of British aviation, and it's said that no other single location in the world has contributed quite as much to the evolution of aeronautical science as this place over such a long period of time.
Of aviation development in Britain, and was the site of the Royal Aircraft Establishment, the military science research facility. During the 20th century, the testing of observation balloons and airships by the Army quickly developed into groundbreaking experiments. It remains world famous for its air show and specialist aviation knowledge. Today, the Farnborough Air Science Trust, known as FAST, are the guardians of Farnborough's engineering legacy.
How important was the RAE and Farnborough in the history of global aviation?
Oh, enormously important. I mean, it brought science and technology into aviation, which was quite a young sport in those early days. But effectively, you had a large number of departments. It did aerodynamic structures, engines, materials.
We tend to associate the evolution of the aircraft with the First World War, but even before the outbreak of the war, RAE here was up and running in a very far-sighted way.
Farnborough was always looking 15 years ahead to actually develop new systems right through to the Cold War. If a new aircraft had to be built, the air staff came to us and would say, what technology do we have in 15 years' time? Because it'll take that long to build the airplane.
So for over a century, RAE really has been a global centre of excellence.
Oh, absolutely.
But what happens to the RAE?
It started to close down in the 1990s when government no longer wished to centrally fund aviation research. But there was 100 years of research here. It was all secret. Nobody knew, very little that went on. So we started collecting all the artifacts and the records from the libraries. The RE had a superb historical library, which went back to 1898. We collected all that, so now we're keeping the legacy in the museum and making it available for the public.
Well, I've just touched the surface, so let's continue our tour, Graham.
The museum's collection is enormous, holding over 500,000 items. It includes machinery, photographs, films and books, all relating to its illustrious history.
Wow!
Just get the light on.
Just remind me how many of these containers you've got again?
We've got 18 40-foot containers and 2 20-foot containers full of artifacts. The Concorde engine there.
That's a Concorde engine?
That's the Concorde, that's a 593.
What's that do there?
There's 2 helicopters through there. There's a Lynx and a Scout, a Navy Scout.
You're joking, that's the design of the atom bomb itself?
But it's not just the paperwork and mechanical parts that have been kept. Their collection of flying clothing has more than 250 items of protective gear.
This helmet is clearly in advance of the Second World War version.
Yes, really, this is late 60s, early 70s, where Americans had loaned us some suits when we were looking at manned space program for Great Britain. And these were some of the very early spacesuits when we had a program to put man into space.
One thing that strikes me, Graham, being surrounded by all of these artefacts, is the millions of pounds and dollars that went into developing each and every one of them. And yet now you could say, well, they're sort of worthless, but at the same time, priceless in the story of aviation.
Yeah, absolutely. You have to understand the past to appreciate what's going to happen in the future.
Farnborough's role was obviously vital in the development of aeronautical engineering in this country, but it took an American cowboy to get the British aviation industry as a whole off the ground, quite literally.
In 1896, the Wild West came to Britain in the form of Samuel Cody. But it wasn't just cowboys and Indians that captivated this American showman.
His interest in kites started as a hobby. He found that flying kites drew a crowd. Therefore, he persisted in flying bigger kites. He developed a system whereby pilot kites would carry a wire into the sky, and that wire would act as an aerial railway for the anchoring of a man-carrying element which would go up and down the wire at will.
Cody believed his man-lifting kites could be used for military observation purposes as an alternative to balloons. These, unlike kites, couldn't be deployed in strong winds.
But he also perceived they could have an engine in, and the first motorised kite that he built wasn't big enough to carry a passenger, but it flew tethered, but it demonstrated that with power you could get airborne from the ground without having to use the string and wind.
In 1906, the Army was convinced, and Cody was made head of the design and manufacture of kites at the balloon factory at Farnborough. But he had grander plans, and he began work on his first aeroplane.
Cody understood it had to be fairly lightweight, but if you're flying on cloth as a kite with a single layer of cloth supporting you, the wing loading, the pounds per square inch that you can develop is quite low. So to get enough lift to build a big mass, you need a big aeroplane. And Cody understood that, and his aeroplanes were always big.
On the 16th of October 1908, Cody made history at Farnborough. His British Army Aeroplane No. 1 left the ground and flew 1,390 feet at a speed of 25 to 30 miles an hour. The flight only lasted 27 seconds, but it was the first powered flight in Britain. Over the next 2 years, Cody continued to improve his designs, and in 1910 he made the longest flight in England, a record 4 hours and 47 minutes. But unfortunately, it wasn't to last, and on the 7th of August 1913, tragedy struck at Farnborough.
Cody was flying over what's now the airfield with a passenger when something on the aircraft broke. Whatever that was, it caused such a violent manoeuvre by the aircraft that the passenger and the pilot both fell out of the airplane. The 7th of August 1913 was the day Cody died, not in an airplane, but having fallen out of one. No seatbelt, no parachute.
Cody was a showman, a cowboy by trade, and a real man of the people. He received a full military funeral. But with the outbreak of World War I, just a year after his death, he was virtually all but forgotten.
By 1916, the workforce here at Farnborough had expanded to nearly 4,000, and they were working around the clock, desperately trying to make up for lost time. Ian, nice to see you.
And you, good morning.
Where better place to talk about the development of early aircraft than here in your workshop?
Pleasure to have you here.
Now, you've got a lovely example here of what was going on at the time to try and create workable airframes and workable surfaces on aircraft. I mean, for those early pilots, being up in the sky, surrounded by nothing more than timber and linen, must have been terrifying.
Well, yes, it looks very flimsy. It's a bit of cloth, bit of wood. But once it's put together, once it's been treated, then it becomes quite a stable and strong environment.
But this is the technology of the Victorian era.
It certainly is, which is why so many cabinet makers went into aircraft production in World War I.
But it just highlights how difficult and how dangerous these early days of aircraft development were.
Exactly. But also in the manufacture, that one of the things that's done to the fabric is what we call doping. Doping being laying this painting on this substance which stretches the fabric and makes it weatherproof.
And it gives it that kind of drum-like...
Exactly, but it also, when you're doing it, gives off a lot of vapour. And at the beginning, that wasn't recognised, and so quite a few ladies and men died as a consequence of inhaling that vapour.
The rate of aviation development from 1908 to 1914 was staggering. By the start of World War I, there were just 40 aircraft in the UK, but by the end of the war, there were more than 20,000.
The initial requirement was for aircraft that would be able to fly over enemy lines and observe what was going on. But then, of course, when you have aircraft that are flying over to observe, the enemy decide they've got aircraft that will shoot you down. So you have to evolve another type of aircraft, which is an offensive aircraft that can defend your observation aircraft.
And that's the birth of the fighter.
Exactly, exactly.
And that, in a way, gives Farnborough its purpose for the rest of its life.
It certainly does. The aircraft industry was established and Farnborough was then dedicated to pure research and development and test.
During World War I, Farnborough had built over 500 aircraft and repaired thousands more. And by 1919, with the conflict over, the emphasis for the Royal Aircraft establishment was now on science and research.
The interwar years saw development continue at an incredible rate. While Britain was suffering in the Great Depression, the RAE were undertaking important developmental work on drones, missiles. They even managed to successfully launch an aircraft from a Royal Navy destroyer by catapult. The engineers and scientists were putting Farnborough on the global map.
Farnborough's development at the beginning of the 20th century had been slow and steady, but World War I had forced them into a rapid expansion. British aviation had to improve and develop to become as good, if not better, than the competition. And with World War II just around the corner, the Royal Aircraft establishment had to be at its best.
Well, by the beginning of the war, in 1939, Farnborough once again was coming into its own. But if I'd have had the chance to wander around the airfield and throw open any of the hangar doors, who knows what I would have seen under investigation. But this, once confidential report, might give me a few clues. It's an historical summary of the Royal Aircraft establishment between 1918 and 1948. But if we just flick through to the beginning of the war, to 1939 to 1940, well, the headings here really do tell you all that you need to know. The aerodynamic department were looking at low-speed wind tunnel testing. The instrument and photographic department were investigating the development of the gyro gun sight. The mechanical test department, well, they were looking at the business of self-sealing fuel tanks. But this is absolutely fascinating. In 1940, the experimental flying department received the first Messerschmitt Me-109 fighter to be captured and brought it here for rigorous trials. And it was flown by one flying officer, J.E. Peabody. But I'm sure he could never have imagined himself that so soon after the start of the war, he'd find himself flying an enemy fighter, learning crucial lessons that he could feed back to the squadrons on the front line.
It's fascinating to see the amount of detailed research that was being carried out, much of which at the time would have been secret. Even with the war raging around them, they were trying to improve pressure injection in engines and the effects of G-force on pilots.
When you look at the breadth of endeavour and inquiry that was going on here, no surprise that some of the nation's best scientists and engineers were recruited to come here to Farnborough to carry on this vital war work.
One of those bright minds was engineer John Charnley. He was recruited by the RAE straight from university in 1943.
I was appointed to the Flight Test Division of Aerodynamics Department. Although I knew nothing about it, that was where I was being posted. And this chap that had been sent to collect me took me into the hangar, and behind the screens was our first jet-propelled aeroplane. I became something of an expert on the jet-propelled aeroplane in its early experimental form.
One of the pioneers tasked with testing aircraft was Captain Eric Winkle-Brown of the Royal Navy. He flew a staggering 487 different types of aircraft. It's a record that is unlikely ever to be broken.
Farnborough, frankly, in the war years was like a pressure pot, because naturally the enemy was improving the performance of their aircraft all the time, and we always had to try and keep a jump ahead of them, if possible. But the Germans were very advanced in performance aircraft, and so it was quite a difficult struggle.
With World War II raging, there was no time to waste. In 1944, test flights from Farnborough totalled over 8,000 hours, an average of 23 hours a day.
The test was to take a Spitfire, climb to 40,000 feet, put the nose down, and tell him that the speed would increase, and on the way down, he'd find he'd lose control. But don't worry about it. By the time you get down to 15,000 feet, it'll be back again and all will be well. And he believed me. Okay. In some aeroplanes, they lost control. In others, the stick got so hard that you couldn't move the stick. So there's nothing you could do about it. You sat there and couldn't pull out until you got down to the lower heights. The characteristics would get back to normal.
But it wasn't just British planes that were being tested. Farnborough's hangars were also filled with countless German aircraft, including the famous Messerschmitt Me-109.
We had quite a few aircraft during the war years land in Britain because they were damaged, shot down and whatnot, and provided they were repairable, we did so, and then flew them to see how good they were. I found German aircraft were very logical in some of their aspects in the cockpit. For example, they used electrics a lot more than we did, and also they had color-coded all things in the cockpit. For example, all the instruments that were associated with oil were a brown color. Anything associated with oxygen was blue. And so they went on color-coding all around. So I thoroughly enjoyed and had a very high regard for German aircraft at that time.
Being a test pilot was a hazardous occupation, and sadly, during World War II, 9 pilots lost their lives at Farnborough. Flying at up to 700 miles an hour wasn't a job for the faint-hearted.
Well, the thing we were trying to do was to make sure that our pilots, our aircraft, were better controlled for operational purposes, fighting, than the enemy. And in that case, you wanted them to make sure they were going as fast as they could, and also that they could be controlled in combat.
The rate of testing was extremely high. I have in my logbook, I think, some 5 occasions where I flew 8 different types of aircraft in one day. That is really pushing it. Because of this situation, this may have accounted for a number of the fatalities we had, because unless you really prepare yourself for this, you are going to get into trouble. I'm only 5'7". I've saved myself 2 or 3 times by seeing the crash coming and curling up in the cockpit. Maybe I was overzealous in preparation, but it paid off. I'm here still.
Thanks to the pioneering work of the likes of Captain Brown and Sir Charnley, flying has become much safer. Their work has informed subsequent generations of aerospace engineers, helping them to design and build much safer planes. And of course, with the advent of modern technology, many of those riskier tests can now be undertaken from the safety of modern simulators, which means that I get to have a go from the safety of the ground. Alan.
Jules.
Very nice to see you.
Good to meet you.
Now, flying is in your blood. You've got many thousands of hours flying behind you.
A few, yes, yes.
And you've taught many others to fly, of course.
Indeed, yes.
When we see on the news the launch of a new airliner, I'm thinking in particular of the latest huge aircraft that's now out there from Boeing. Just how risky is it for the test pilots taking something like that up?
It's not as risky as it was. The lessons that were learned, the science of aeronautics has improved, and our knowledge has improved. So before an aircraft even flies nowadays, the computer modeling that is used with, again, it's hand in hand with computer technology, shows that the machine is going to fly and it probably will achieve the targets that was set out from the drawing board. That said, they still don't fully know, hence they've got to get airborne and try it out and see. So there's still risks involved, but those risks are hugely mitigated nowadays, absolutely.
In this modern age of commercial air travel, do you think many of us have lost sight
of those early test pilots and just what they achieved?
Yes, because we have these shiny, beautiful, safe vehicles, our airliners. And we just get into them and off we go on holiday. And what's gone into that science, yes, absolutely. These are heroes, remember? Every schoolboy in the United Kingdom would know who the latest test pilot was.
Well, today you're going to give me a chance to fly next to you, Alan, showing me the ropes, seeing what kind of a pilot I might make in one of your very beautiful looking simulators.
Yes, absolutely. I'll be delighted to show you what the thing can do.
He says with a smile on his face.
Do you have a sick bag?
Well, you know what's coming, don't you? Come on, let's go and have a look.
Very good.
The pioneers of aviation during the 20th century took untold risks. At Farnborough alone, 9 test pilots died in the name of science. I'm certainly not brave enough to follow in a test pilot's footsteps. So with the use of modern technology, I'm going to fly a Boeing 747 simulator, which is used in the training of pilots today. I have no idea quite what I'm letting myself in for.
Okay, Jules, this is my colleague Paul.
Hi, Paul. Nice to see you.
Hi, Jules. Nice to meet you.
I can't believe I'm sat in the pilot seat of a jumbo jet. This is a boyhood dream come true. Thankfully, I'm not risking my life or indeed theirs, but I have got a lot to learn. Paul, are we ready to go?
We're ready to go.
Right then.
Let's go. Have control column here.
Yep.
That's to descend. That's to climb. Left and right. Very small positive corrections. It's very, very sensitive. As we go down the runway, I'll tell you to rotate. When you do rotate, just slowly pull back. Try and put the centre of the screen, that little square dot in the middle, into the magenta cross. Should we give it a go? Now setting takeoff thrust.
This is astonishing. I've always wanted to see this.
And rotate, slowly back.
And we're in the air.
We're in the air. Gear up. Gear up. Bring the nose right up into the cross. Take some of the pressure off you and set the autopilot. Take your hands off the control column.
So now we're flying.
Now we're flying, the aircraft is flying itself.
Now at the moment everything's calm and organised and everybody's back there enjoying their flight, I hope, getting into the movies and the drinks and so on.
Yes.
What could possibly go wrong?
Should we have a look? Shall we?
He's looking.
What's your fancy, Alan?
Well, I get to play God, and what we're going to simulate is a failure of one of the autoflight systems, where you, as the pilot, are going to rescue the day.
Well, with some help.
So if I disconnect the auto throttle,
Yep.
close the thrust levers, we'll just let the autopilot do its thing. So we've got our first warning, which is auto throttle disconnect. You can see the caution light comes on.
So the aircraft is losing power.
It is losing power now. We're only at idle thrust. The thrust levers are closed.
Yep.
And what's happening now is the aircraft is putting the nose up, trying to increase the lift from the wings.
So it's doing that?
So it's doing that.
Yep.
And as you can see here, on the artificial horizon, in fact, the nose is slowly coming up. And we're going into the yellow area here, which is the buffer warning, which is a warning of an oncoming stall. There's our second warning,
Yep.
which is the airspeed low warning now. Now you can feel the stall coming on.
Starting to shake.
Starting to shake.
Yep.
And then the final bit that we have is the stick shaker, which comes in, and from that we recover. So push the nose forward.
Well, that gets your attention. Whoa! Wow. Okay. Yep.
Bring the thrust in, increasing speed, bringing the lift back into the wings.
Keep heading down.
Keep heading down, and then slowly, but not too fast because you'll put it back into a stall.
So you're pushing it back through the
Pushing it
curve,
back-
aren't you?
Yeah, you're pushing it back in to create the lift.
Yeah.
And we've lost 1,000 feet in that action just to recover the aircraft and bring it back into a flying state. We level off at around about 7,000 feet.
Yeah.
And the aircraft's flying again.
We have successfully got ourselves airborne. We've overcome the challenge of what could have been a very catastrophic in-flight scenario. Should we go and land?
Yes.
I can't wait to see that runway open up.
You have control.
Clear land, 27 left, Jules 01.
We are coming into land at Heathrow, and I'm seeing what is a very familiar airport to me in a completely different light. 400 feet. Here we go. There's the terminal buildings. There's runway. Nicely lit up.
300.
Now look out the window, look down the end of the runway.
200.
Yep.
Don't let the end of the runway sink or rise. Just keep it where it is in the window.
Yep.
And you'll line perfectly.
100.
100 feet,
Yep.
50 feet, the
50.
thrust starts to come
40.
off.
30.
Close the thrust
20.
levers. touches the runway, speed brakes
And we're down.
deployed, and we're down. Still flying though, still doing 140 knots. Slowing down, slowing down, slowing down. And I have control.
Well, captains, both of you, thank you very much indeed, Paul.
Thank you.
Alan, thank you.
Very welcome.
And it's nice to know that we're all that bit safer thanks to the work that you do and these remarkable simulators.
Indeed.
As well as testing the limits of aircraft at Farnborough, they were also interested in testing the stamina and the endurance of the pilots, if you like, the human factor.
In 1945, the Institute of Aviation Medicine, known as IAM, moved in.
The IAM's role was twofold. Firstly, to investigate the effects of the various stresses encountered in aviation on pilots, and secondly, to assist the Royal Aircraft Establishment in developing new items of aircrew equipment to protect pilots against those stresses.
The IAM pushed the human body to its limits. From G-force, the stress of heat and cold, noise and vibration, to spatial disorientation and human error. Every possible scenario was tested. And when they ran out of volunteers and pilots, the scientists found themselves in the firing line.
The scientists at Farnborough used themselves as experimental subjects, and two of the most famous regard Roland Winfield and the Snatch experiments, which were designed to pick reagents up from the ground without having to land an aircraft. So the Snatch had to be clean, and then they had to be wound up into an aircraft safely without losing them off the end of the rope. The other famous one at Farnborough involved Edgar Pask, who was an anaesthetist, and this involved making himself unconscious and being thrown into a swimming pool wearing different types of life preserver to test which were most effective. You couldn't be a good human physiologist unless you regarded your body and those of your colleagues as something to be used, and if necessary used up, was absolutely true.
The IAM became a world-leading centre for aviation medicine research. In 1994, the government combined their resources and the centre moved, forming the new Defence Evaluation and Research Agency of Human Sciences. Today, it's based at RAF Henlow, but the testing hasn't stopped.
The business of aviation medicine hasn't really changed much over the years because the same hazards still exist in the flight environment. So pilots still need to understand about the dangers of hypoxia or low oxygen levels.
When one gets hypoxic, there is less oxygen being delivered to the body's organs, and when one does get hypoxic, brain function tends to diminish. Traditionally, what we do is give people their hypoxia experience in a hyperbaric chamber, such as this one. What we would do is sit them in here and simulate taking them to altitude by sucking out some of the air that's in here. We now moved away from this type of training, and we do far more ground-based hypoxia training. In that situation, we keep the pressure the same, and it's the percentage of oxygen in the air that we decrease. Pilots will be flying a flight simulator and doing flight-related tasks, whereas non-pilots will be doing simple cognitive tasks such as sums. These things bring out the symptoms of hypoxia, such as tingling of the fingers around the mouth, and some people even experience changes in mood and develop a euphoria.
So if we can give our pilots and our air crews the training that they understand what some of the symptoms are, whether it be of hypoxia or spatial disorientation or things that they should do if they're in high G performing aircraft, then it's really all about delivering that training so they can prevent getting into adverse situations in the air and therefore reduce the risk to their life.
The work undertaken by the Institute of Aviation Medicine meant the human factor wouldn't limit any technical advances in aircraft design. Pilots today can take their aircraft to incredible heights at incredible speeds while performing death-defying manoeuvres. But throughout aviation history, some of these advances came at a high price. One aircraft that found itself grounded after only 2 years of service was the de Havilland Comet. It looked to take the world by storm, until two unexplained mid-air disasters rocked the aviation industry.
The first flight of the de Havilland Comet in 1952 in passenger service was a huge step forward for the passengers. It halved the journey times to the Far East and to South Africa. It allowed the passengers to travel in a pressurised cabin for the first time that was comfortable, that allowed them to fly at high altitude above the turbulence, and it really made a step forward for passengers.
A year after entering service, problems started to appear. Two fatal crashes during routine flights grounded the entire fleet, and Farnborough's scientists were called in to investigate.
One of the pieces of work that Farnborough did was to take a fuselage just like this one and to put it into a water tank. By putting it into a water tank and pressurising the water inside the cabin, it simulated the pressurisation of the cabin as it would go through a normal flight. By doing that, they could do a flight in 10 to 15 minutes and really accelerate the wear on the cabin that it would see in normal service. And sometime in June 1954, the aircraft that was being tested broke, and when they drained the water out and investigated the fuselage, they found out that there was a big crack growing from the forward port escape hatch.
The constant pressurisation and depressurisation of the plane's fuselage during flights had forced little defects in the skin to grow and expand, which over time produced large gaping holes.
This is a typical piece of Comet skin. It shows how thick it was, just under 1 millimetre thick around the windows, and it shows the rivet holes have been punched in, and it's from these rivet holes that little defects grew, and just like you can see here, the constant flexing of the fuselage with pressurisation and depressurisation caused cracks to grow. And it's these cracks that grew and grew during each flight until the aircraft crashed. The de Havilland Comet became a successful design, flying for 60 years with the military as the Nimrod, and the lessons learnt at Farnborough meant that windows changed in their design, that the skins of aircraft became thicker, and we designed with fatigue in mind. This put Farnborough at the forefront of aviation research and also meant that air travel was much safer than it was before.
The legacy of air crash investigations lives on in Farnborough today. The modern air accident investigation teams are based on the outskirts of the modern airfield. Every year their teams are called in to research air crashes, not least the loss of flight MH17 that was lost over the Ukraine in July 2014. So the name Farnborough hasn't just become synonymous with flight, but crucially with flight safety.
The Royal Aircraft Establishment at Farnborough's contribution to the development of world aviation is endless. No other aeronautical site in Britain has had such an unbroken record of involvement in research.
The RAE Materials Department had joined the race to find the holy grail of material sciences, how best to combine the strength of metal with the lightness of plastic. And in 1963, 3 RAE scientists came up with the answer. Peter, carbon fibre has come an awfully long way since the early 1960s.
It has indeed, yeah, indeed.
What is it now that makes it so different to what it was then?
It's our knowledge of it and how to use it and how to process it. It's moved out of, if you like, the laboratory into everyday use because we understand it. The NCC is about accelerating innovation, taking it from the laboratory and really helping industry work out how to use these materials, how to manufacture them, how to make them safe and take advantage of them, if you like, all at the same time.
What makes it so applicable to aviation?
It's fundamentally the strength to weight ratio. You get the same strength in a very, very light piece of structure. The lighter you make the aircraft, the more passengers you can carry, the less fuel you use, all those sort of things that make aviation more and more efficient. And it is a phenomenal material. If you look at this here, the strength to weight, you can feel how light that is, but you just feel how incredibly stiff and strong that is.
How important a discovery was this?
Incredibly. Modern aviation just would not be the same without it. There's no way we would be flying aircraft the distance we are, with the economics we do, with the emissions that have been achieved nowadays.
And of course now it's creeping into everyday life, particularly in sport, from boats to bicycles to bats. What are you doing with it now?
What are we doing? Well, let me just show you some of the advanced technology that's being developed for the future. Okay, so now I'd like to show you the real cutting edge of what we do with carbon fibre. Here we're using robots to lay up carbon into moulds and make products. I'd like to introduce you to Ben from GKN. Ben?
Hello, Ben.
Hello, all right.
Nice to see you. How are you?
Nice to meet you.
Wow, this is quite impressive. Which part of an aircraft is this?
So this is actually a winglet skin, which is a lower skin of a winglet component, which sits on the end of an aircraft wing.
And what does it do for the aircraft?
Well, this effectively makes the wing appear like it's longer to the aerodynamics. It unwinds the airflow, makes the aircraft more efficient, uses less fuel, less CO2 emissions, but without occupying any more space. So when it comes to moving the aircraft around the airport, it doesn't occupy bigger space, they don't need bigger gates and all that sort of thing. So you're getting more efficiency without the impact of the airfield.
How much is aviation taking on carbon fibre? How much of an aircraft can be made from carbon fibre?
Well, today about just over 50% of the current breed of aircraft are made out of carbon fibre. That's progressively grown from the early applications in the 70s, which were just small parts, and as we've become better at understanding how to use the material, how to make some of the supercritical parts like the wings and other parts, have the confidence in using the material, then that's progressively found its way across the aircraft.
I suppose, Ben, when we come back to that issue of weight, so critical to aviation.
Super critical, yes.
How much weight does this add to a standard aircraft wing?
As we know, carbon fibre itself is a very light material for the strength properties it gives you. You could probably imagine something this size, what it would weigh and how heavy it would be if it was made from aluminium, for example. So I don't know if you would just want to grab it and you'll see exactly how light this is.
I'm not going to break it, am I?
I hope not. So there you go.
That's incredible.
Yeah.
That's lighter than a surfboard, isn't it?
It is indeed.
That's ridiculous.
But like I say, when you consider how strong it needs to be, it's quite incredible the weight we can actually get it down to still perform as it should do on the aircraft.
Ben, what exactly are these robots doing?
So these robots are actually laying down individual toes of carbon fibre. They go into different orientations, and this is what gives us the strength of the component by just different directions and different layers of this material. The reason we use this material is because it's very strong in tension. So if you wanted to pull on the end of that, we never break it, we both fall over and look silly.
It's not a Christmas cracker, is it?
It's not quite.
It's not going anywhere.
I hope it doesn't go bang anyway. When you look at it in the crossways direction,
you can tease it apart really easily.
It's actually very fragile, which is why we need the different layers of orientation to get the strengths we desire.
Well, it's been a fascinating opportunity to see behind the scenes and to see modern manufacturing, as you say, at its absolute best. And certainly next time I go on holiday, I shall look again at the winglets out of the window, and I'll think of you, Ben.
Thanks very much.
The groundbreaking work carried out by the scientists at Farnborough in developing the strength of carbon fibre allows designers to juggle the demands of aerodynamics, fuel savings and engine noise. In today's world of mass commercial flight, making planes bigger and faster is essential.
The NCC is a fascinating facility. This is just one of the ovens they use to finalise the process of turning carbon fibre into aircraft components. But when you think about the 50 years or so that have passed since this material was first invented, trying to keep up with the huge advances in aviation technology can feel like quite a daunting task. But I think one thing is for sure, carbon fibre is here to stay. Until, of course, they come up with something even lighter and even stronger.
One of the key tools in aviation testing is the wind tunnel. This massive 24-foot tunnel was built in the 1930s and could simulate winds of over 100 miles an hour, allowing scientists to analyse and improve the aerodynamics of aircraft. And with the development of the jet engine, a whole new spectrum of speed was unlocked: supersonic flight. When the British and French aviation industries combined to develop a new supersonic passenger airliner in the 1950s and 60s, where else would they come but Farnborough to test their design?
Sadly, I was never lucky enough to take a trip on a Concorde. These days, all of those that did fly have now been grounded, and without exception, they're all preserved in museums throughout the world. To take a closer look at what makes this aircraft so special, I've come up to the Imperial War Museum at Duxford, and this aircraft is particularly unique because this was one of the first.
The supersonic passenger airliner first flew in 1969 and entered service in 1976. British Airways and Air France built 20 Concordes in all, with 14 making the transatlantic trip from Europe to America.
I think part of the beauty of Concorde is in its perceived simplicity, but do not be fooled. On a conventional aircraft wing, for example, there are up to 50 moving parts. On Concorde, there are only 6. There they are, either side of those 2 enormous Olympus engines. When you get up close to Concorde, you realise that with very few exceptions, there isn't really a straight line on it. But it's the wing and this leading edge of the wing that really tells the story. It's a complicated series of mathematical equations that have created curve upon curve. In particular, this twist and droop running right down there to the wingtip. What it means is that Concorde had incredible stability at low speeds, but low enough drag to go supersonic. It is an essay in airflow. But to be honest, to really understand it, you need a physics degree. Just when you think you've mastered the simplicity of Concorde, you come into the cockpit and you realise that you've learned absolutely nothing. It is a maze of dials and buttons, and I suppose really goes to the heart of the development of this aircraft.
Well, it does. I mean, this was a pre-production model. There were 2 prototypes, and then there were 2 pre-production models which were used for testing. This was the British pre-production model.
And am I right in saying that this was the fastest Concorde that ever flew?
Yes, it was. This one flew at 2.23 Mach.
2.23 Mach, so in pounds and pence that's
1,450 miles an hour.
Isn't that astonishing?
That's absolutely astonishing.
I mean, that's virtually London to New York in 2 hours.
2.5, certainly, but yes, I mean, you certainly would arrive in New York 2 or 3 hours before you'd taken off at Heathrow.
That's incredible, isn't it? But in many ways, David, Concorde challenged and broke many of the accepted parameters for the operation of aircraft.
Well, it did. It was very experimental in many ways. Obviously, there had been supersonic fighter jets and things like that that went before, but transferring that technology to an airliner that could carry 100 people with great reliability was a whole different ballgame.
But it was operating in extremes of cold and heat.
Indeed it was. It would take off from Heathrow on a cold winter's day in negative temperatures, and by the time it was flying at 60,000 feet at 1,400 miles an hour, it was probably 120, 130 degrees centigrade. So the fuselage expanded, and expanded by around about 9 inches in whole units.
9 inches, so almost, what, 25 centimetres?
Absolutely.
I suppose one of the most headline-grabbing features of Concorde, apart from its incredible speed, was the nose, and the fact that the nose would move. Why was that such an important thing to create?
Well, basically because the wing is designed for supersonic flight. As the plane slows down to come into land, it has to take up a fairly steep angle, which we're all very familiar with.
It flared hugely, didn't it, as it landed?
Absolutely right.
Yeah.
Well, of course, the pilots couldn't see anything. I mean, they were facing the sky. So the droop nose was the solution. This particular aircraft, interestingly enough, because it was the first time that we had this visor that you could see out of. The visor lowers first, then the nose goes down to 5 degrees, and then ours goes down to 17.5. When they then started to get the commercial airline pilots involved and they started to fly it and test it out, they said, well, we can't see where we're going. Like the bonnet of a car, they had nothing at the front to look at when they were trying to land.
I mean, I sort of take the point. There isn't a huge area of view there, is there?
There's not a lot of a view, but all that falls away, of course, when you're coming into land. But they hadn't got this front of the bonnet, so they decided that rather than 17.5 degrees, 12.5 would be better.
You know, this aircraft in particular, to me, is something of an old friend. It's one of the very first aircraft I ever saw here at Duxford as a young kid of about 7 years old. And here I am, still coming back to enjoy it.
Glad to hear it.
The Concorde bug has bitten.
Yes,
David,
absolutely.
thank you very much.
Pleasure.
After the tragic crash in Paris in 2000 and dwindling passenger numbers, the Concorde fleet was retired in 2003, ending commercial supersonic flight. But failures in planes don't stop development. They just make engineers and scientists more determined to succeed. And who knows how aviation will develop in the future. The history of Farnborough will be forever linked with the history of British aviation, but there can be few other airfields that have had such a long-lasting or indeed global impact on the story of international aerospace engineering. The RAE and all the other research institutions that were once based here have now long gone, and Farnborough is now simply an airport.
But thanks to history and preservation, the stories and the lives that surrounded those early pioneers of flight will never be forgotten. For over a century, the legendary tales that have surrounded our great British airfields have inspired generations of people, including me, which is why I am on a personal mission to cross the UK to visit some of our most important airfields, to understand not just about their contribution to our past, but importantly, how many of them have helped define our future. From the UK's first flight, through to groundbreaking innovations such as carbon fibre and the jet engine, and the extraordinary effort spent on preserving our aviation heritage. Join me as I explore the story of the airfields that have helped shape Britain and the world. I'm here at RAF Biggin Hill, one of the most famous airfields of the Second World War. Biggin on the Bump, as it was known, became synonymous with the Battle of Britain, the aerial campaign that thwarted Hitler's attempts at invasion back in the summer of 1940. The pilots that took off from this runway faced overwhelming odds, but in overcoming them, they wrote themselves into the history books.
21 threshold QFE 978. We're on runway 03.
The geography here at Biggin Hill ensured the creation of an airfield back in 1917 towards the end of the First World War, and its unique characteristics have meant that nearly a century later it's still a very busy place.
2, 3.
That is correct. Next report ready to taxi.
Bob, very nice to see you, sir.
Hello.
Admiring an airfield that you have studied for years.
Yes, I have.
So tell us, why was Biggin Hill founded here?
It started life as a wireless testing station, and they came across this field here, 80 acres, absolutely massive. It was 650 feet above sea level, but it was the perfect place. And they perfected communication between aircraft in flight and the ground through this amazing new technology.
Hence, Biggin on the Bump.
Biggin on the Bump, an upturned saucepan. But as they came into land, there was a little hill, and they used to stick their noses in the air over the other side, and it became known as the Bump.
And I guess its role in the First World War really was the kind of precursor to the Second World War, when Biggin Hill really does earn its wings, as it were.
Well, it soon became a senior sector airfield. It became the most famous fighter station, not only in the country, but in the world. More than 1,400 enemy aircraft shot down. There was a ring of fighter stations around London, but this was the strongest link defending the southern approaches.
In the late 1920s and early 1930s, Biggin Hill was given a much-needed revamp, the provision of new hangars and these E-pens to protect aircraft and their ground crews against the possibility of air attack. And all of that, of course, was just as well, because the clouds were gathering over Europe as war loomed on the horizon.
In 1935, news reached Britain that Hitler was rumoured to have a death ray, using radio waves to destroy towns and cities. So the Aeronautical Research Committee asked radio engineer Robert Watson-Watt to explore creating a death ray for Britain, specifically to be used against aircraft. Watson-Watt quickly proved the death ray idea to be impossible and suggested that perhaps radio waves might be of more use in detecting and tracking enemy aircraft.
51 Uniform Bravo, Lufthansa 428, turn right, resume your own navigation to position Tendo and then NATO.
At its most simple terms, the primary radar works by emitting a large pulse of radio energy. It bounces off the metal in the aircraft and it returns to the radar sensor. Because we know how long that takes to happen and we know which direction the signal is being aimed, we can tell the range of the aircraft and how far it is away from the radar head. That then developed even further so that we can interrogate the flight management computer for certain data, and we can now tell the intended heading of the aircraft and its selected flight level. That in itself provides a huge safety benefit to us because we can automatically check that against the clearance we provided the aircraft so that we can take early intervention if it's necessary.
Today, the National Air Traffic Services, known as NATS, control the UK's radar system. They handle over 2 million flights a year and over 220 million passengers in UK airspace, controlling both civil and military aircraft.
If we didn't have radar, we really are reliant on the aircraft to report their position, and really with the number of aircraft that we have to maintain and keep in the air at any one point in time, that just wouldn't be a practical way, and there would just be so many delays, it would be truly awful.
But back in the 1930s, radar was in its infancy, and RAF Biggin Hill needed all the help it could get defending London against the approaching Germans. The terrifying effectiveness of the German Air Force had become all too apparent during the Spanish Civil War. And here in Britain, there is a renewed urgency to put this new technology to good use. Between 1937 and 1939, radio masts, just like the one behind me, were put up all along Britain's coastline. It was the world's first air defence system. They called it Chain Home.
Well, Andy, it is amazing what you find lying around the Essex countryside.
Absolutely, Jules, you find all kinds of different things, including a 360-foot radar tower.
And where was this one originally sighted?
It came from Canooden, which is near Southend, about 25 miles from where we stand now.
Well, the best view of it's got to be from over there, isn't
Absolutely.
it? Well, Andy, there's no getting away from the impressive nature of the Chain Home array. But just exactly what was it and how did it work?
Chain Home was the United Kingdom's air defence radar system in the Second World War. It was designed and developed during the middle to late 1930s, and the original station would have consisted of 3 or 4 of these huge 360-foot towers, separated by about 100 feet. And between them, between the cantilevered platforms, would have been slung wire antenna arrays. So the whole of the east coast of the UK was pinpointed with these antennas all the way along. Somewhere beyond us over there would have been 4 wooden towers, 240 foot high, and they held the receive dipoles. This was a pulse system, so a pulse of RF would be transmitted from one of the curtain arrays slung between the transmit towers, and it would floodlight the area in front of the radar, up to 200 miles away. And then the receivers would pick up the very, very tiny signal that's been re-radiated, reflected from the target.
So it gave a sense of direction and height?
It gave direction and height, yes, and it meant that we could scramble our aircraft and they could be in the right place at the right time.
Could it tell you how many aircraft were in the air?
Not on its own, but a trained operator could be able to have a good estimate of the number of aircraft by looking at the size of the return signal.
Its great champion was Dowding. Tell us about the Dowding system.
Well, what Dowding did was he looked at the problems of air defence as a whole. So the whole system of air defence, from the anti-aircraft guns to the searchlights, was all integrated into this whole Dowding system, which meant nothing worked on its own. It was all, if you like, orchestrated from a central place.
The Dowding system was the key instrument of war in Fighter Command's armoury, denied the enemy the element of surprise. Air Chief Marshal Hugh Dowding developed a series of reporting chains. Information was sent from the chain home to Fighter Command, who would then in turn relay details to the operations sectors like Biggin Hill. They would then scramble the airfields and the squadrons.
Now, these do look like pretty juicy targets for the Luftwaffe. How many of these stations were destroyed and attacked?
Well, they did try and destroy them, but they're mostly air. So bombs landing, other than a direct hit, did very little damage. Not until the middle of the war did they even realise that it was a radar system.
When we think of the Battle of Britain, we tend to, of course, focus on the famous few that Churchill describes, the fighter pilots. But actually, it's the backroom boys who came up with systems like this that we really have to thank.
That's right. I mean, the fighter pilots wouldn't have been in the right place had it have not been for radar, because we were so outnumbered. Without chain home, we would almost certainly have lost the Battle of Britain.
Before World War II, interception rates of 30 to 50% were considered excellent. Now, with the Dowding system in place, Fighter Command achieved well over 80%. Without Chain Home, Biggin Hill's organised defence of London would have been virtually impossible.
The effective development and implementation of radar could not have come soon enough. Hitler's invasion of Europe had proved to be a resounding success, and his next objective was to knock Britain out of the war.
When in 1940 it became evident that Churchill wouldn't surrender, Hitler tasked his military to draw up plans for an invasion of the UK. What they came up with was codenamed Operation Sea Lion.
There was a great deal of optimism in the higher echelons of the German armed forces that a successful invasion of Britain could take place, especially in the army and in the air force, the Luftwaffe. But there was a greater reluctance to mount an invasion by the German Navy. Grand Admiral Raeder, the Commander-in-Chief of the German Navy, realised that because most of his surface fleet had been destroyed or knocked out during the Norwegian campaign that had been fought between April and June 1940, he was very worried that the Navy wouldn't be able to escort the invading forces over the Channel successfully.
By August 1940, a large number of vessels, including 2,000 barges, had been assembled on the Belgian and French coasts. But to launch an invasion on Britain, Hitler needed to control the English Channel. To do this, Germany needed control of the air, and that meant taking on the Royal Air Force.
The Germans were going to use 13 divisions in the initial assault on southern Britain, the objective being London, of course, and eventually the invading force would have totaled 39 divisions, including 15 to 17,000 men, but also including 3 panzer divisions in the initial assault, each of which had about 250 tanks. So it was quite a formidable force. I mean, the British, one must remember, had lost a lot of equipment in France. The men had come back with their rifles, but very little else. A lot of guns, tanks had been left behind. And Britain was really very, very denuded of armaments.
Hitler's Air Force entered the battle with around 1,300 bombers and dive bombers and about 900 single-engine and 300 twin-engine fighters. Significantly more than the 600 that RAF Fighter Command had available at the time.
The Germans had a very healthy respect for the Royal Air Force, and they realised that the full resources of the Royal Air Force hadn't been thrown into the Battle of France, as the French government pleaded with Churchill to do so, because Churchill was very conscious of the fact that the Royal Air Force Fighter Command was needed to defend Britain. Hitler says in his directive that it was vital that the German Air Force destroys the English Air Force, and he calls it the English Air Force, not the Royal Air Force. It was vital to knock the RAF out.
By July 1940, the stage was set for the first major campaign between two rival air forces. Now, the Germans, of course, had their bomber fleet and the highly regarded Me-109 Messerschmitt fighter, but in some regards, well, the RAF held all the aces. 2 aircraft that would become synonymous with the exploits during the Battle of Britain, the Hurricane and the Spitfire. Well done, Paul. Well, you know, my day just gets better and better. Look at it. We're on Biggin Hill Airfield. We've got 3 beautiful aircraft to look at. The Hurricane, of course, and these 2 Spitfires. I mean, this really is the story of Biggin Hill, this aircraft.
It is, yeah, it's iconic. I mean, Biggin Hill's an iconic airfield, but the Spitfire is really the icon of the Battle of Britain, if you like.
Well, come on, show me round. I can't wait to get up close. The design of it, these elliptical wings, very much an icon, again, of the period of the 1930s, and yet have produced the most beautiful aeroplane.
Well, that's the real thing about this. It's an iconic shape, but it's really just practicality. It was the most efficient shape they knew of at the time. And Mitchell, who designed it, said, I don't care what shape it is as long as it covers the guns.
Little did he know he was creating not just a design icon and a beautiful aircraft, but a war-winning solution. When I talk to pilots who flew these during the war, they say it was really an extension, if you like, of themselves.
Oh yeah, many pilots have commented that you used to strap the airplane on like you were wearing it. And you go off and fight. You're not even conscious of the airplane when you're fighting with it. Fingertip movements on the controls, it's so responsive. You think about turning, it's already turning for you. For me, the shape of this airplane is so beautiful that we'd already won the war on style. You know, with airplanes that looked and sounded like this, we couldn't have lost.
When you talk about sound, that of course comes from the famous Merlin engine, and there's a beautiful example of it just over here, all uncovered for us. It's a ludicrously complicated looking thing. How did that compare to the enemy machines, the Messerschmitt in particular?
The Messerschmitt was a little bit faster in level flight, at a better rate of climb and a steeper climb angle, so it could get itself out of trouble. But it also had the technique of diving. A Messerschmitt could dive away from a Spitfire. The Spitfire trying to pursue would cough and cut out because of the design of the carburettor.
Was that ever overcome?
It was overcome in a way, actually a very simple device, like a washer that was inserted in the carburettor, stopped all the fuel moving to the other side of the float chamber. That was a temporary solution.
But many pilots talked about the manoeuvrability of the Spitfire over the Messerschmitt. What was it about the Spitfire that gave it that edge?
It was slightly more manoeuvrable than the 109, certainly. It was a very complicated machine, but very advanced.
The first prototype of the Supermarine Spitfire flew in 1936, and it was placed into production in 1938. At the outset of the Battle of Britain, only 19 squadrons had Spitfires compared to 30 armed with Hurricanes. The Supermarine's elliptical wing design made it fast and manoeuvrable in a dogfight. The Rolls-Royce Merlin engine gave it a speed of over 350 miles an hour. It had a wingspan of over 36 feet and a maximum speed of 408 miles an hour. Its firepower developed from 8 Browning machine guns to 4 powerful 20mm cannons. Overall, the Spitfire squadrons were responsible for shooting down 521 enemy aircraft, an average of 27 per squadron. Well, we've talked about that sense that pilots could virtually wear their aircraft. I know we're not going to get a chance to fly in one today, which I would love to do, but can I have a sit in the side?
Certainly can.
Which one? This one?
This one over here.
I have been looking forward to this for a long time.
You've already got the Spitfire grin, you're not even in it.
Ah, you see? The Spitfire grin.
Oh, yes.
Well, that's a given. This is just beautiful. What's the best way?
The way to get in is to hold onto the armour plate here and the windscreen frame that you've got there.
Yep.
Stand on this ledge and then stand on the seat.
OK, here we go. My first dive into a Spitfire. And then just pop my feet in.
That's it, yeah, put your feet down there where the rudder pedals are.
Oh, you talk about that Spitfire grin. It's a glow that kind of flows through you.
Oh, yeah, yeah. And it happens to just about everyone their first time, and their second time, and their third time.
Now, you've been involved in restoring these aircraft for many years, Paul. How many man-hours did it take to build one?
To build one originally, just over 15,000 man-hours.
15,000? And keeping them in the air, in particular at stations like this one at Biggin Hill, which were under such heavy attack during those heady days of the Battle of Britain, must have been an uphill battle.
It was a round-the-clock process. They never stopped. And you'd always get the chief engineer on the squadron saying, you know, I want these serviceable for tomorrow morning.
Regardless.
Yeah.
Regardless.
And they'd move heaven and earth to get as many aeroplanes up as possible.
But of course the Spitfire, although the icon of the Battle of Britain, was outnumbered, not by the enemy in many respects, but by the Hurricane. More Hurricanes flew in the Battle of Britain than almost any other aircraft.
It's true, yeah, there were more Hurricanes. In fact, 2/3 of the fighter force were Hurricanes. Correspondingly, they got more kills than the Spitfire. They were sent after the bombers in a lot of cases because they were very good for shooting with, very stable, and could take a lot of punishment because they were fabric construction down the back of the fuselage especially.
Now I'm going to chance my luck today. I've already had a chance to get into a Spitfire. Can we have a look at that Hurricane too?
Certainly can.
The first prototype of the Hawker Hurricane was introduced in 1935 and went into production in 1937. It was the first single-wing or monoplane RAF fighter, and in total 14,583 were manufactured. With a wingspan of 40 foot and a Rolls-Royce Merlin 3 12-cylinder liquid-cooled engine, it was the first RAF aircraft capable of a top speed in excess of 300 miles an hour. The fighter plane carried an armoury of 8 Browning machine guns mounted in its wings. Although largely overshadowed by the Spitfire, it's estimated that its pilots were credited with 58% of all enemy aircraft destroyed, an average of 53 per squadron.
So this is your Hurricane?
This is a Hurricane, and everywhere you look on a Hurricane, it's chunky. It's got a great big thick wing, which made it very stable for shooting.
And I love this characteristic ribbing almost. It's this wonderful fusion between the newer technology at the front and the older timber and canvas at the back.
It is a bit of a mixture. I mean, the engine's the same as the Spitfire engine, but apart from that, it's pre-war technology. It's like a biplane almost.
But how robust were these up against the German aircraft?
These were very robust, but the key to this is a bullet would go straight through, hopefully, without hitting anything important on its journey. And you could easily repair that by just letting a patch in.
Ah, yeah.
Didn't have to rivet or cut metal. You literally just dope a patch on.
And there was quite an important equation between fighters being built and fighters being lost. How quick were these to make compared to a Spitfire?
They were, you could shave a third of the time off. They were about 10,000 hours to build.
Really? It's hard to believe that these were somehow perceived as less glamorous than the Spitfire, given the job they were doing.
They're not as glamorous, you know, they're fabric and wood, and you know, they don't get the blood racing like a Spitfire does unless you're actually flying one. But one of them has to get the glamour, one of them has to do the work, and it's the Hurricane that's the workhorse, shall we say.
If you had to choose between the two, what's your favourite?
Well, I'm a Spitfire junkie, so the heart rules the head on that one.
Yeah, I mean, I have to confess, I'm going to put my colours on the Hurricane mast. I love them. I love their squat shape, and I love the fact that they were the underdog in a way in technological terms, but they were the backbone of the fighter force then. But either or, I'd have one for Christmas, wouldn't you?
Couldn't have done without either of them.
Spectacular though these planes are, the experience must have been terrifying. With the gun button set to fire, it was every man for himself. With your own personal survival and the fate of your country at risk, the stakes were high.
Now, the main objective of those Luftwaffe raids was to knock the RAF out of the war, and until it was defeated, Hitler's planned invasion would be all but impossible. Biggin Hill itself was attacked numerous times throughout August and September of 1940, leaving the airfield pretty much devastated, but it never shut. And it's against that backdrop that ground crews worked tirelessly day and night, not just to keep the RAF in the air, but importantly to keep Britain in the war.
The members of the Women's Auxiliary Air Force, or WAAFs as they were known, played a vital role in fighter command during the battle. They used the huge chain-home radars to locate air raids and report their positions, as well as plotting these reports in the control rooms.
We're here in the Battle of Britain bunker at RAF Uxbridge. We are 60 feet underground, and this is where the Battle of Britain was operated from, was controlled. Around this table you would have had up to 20 members of the Women's Auxiliary Air Force receiving information about incoming bombers, plotting it on this map in front of us, and then helping the other RAF bases to scramble fighters to intercept those incoming bombers. The Battle of Britain really was the first point at which we were truly tested as a service, and as such, if we were going to have any chance of defending against incoming attacks, then as many men standing in this room as possible had to be flying. And if that was going to be the case, then we simply had to substitute women for men in these roles. So by the summer of 1940, there would have been 20 Women's Auxiliary Air Force members standing around this table doing the jobs that only months earlier men would have been doing.
200 women worked at Biggin Hill. Their roles varied from catering and washing pilots' clothes to the more technical side of radar operations and servicing aircraft.
Of course, very quickly, women proved that they were more than capable of holding their tongues, of maintaining their cool under the most intense pressure, even to the extent that 3 WAAF who worked at Biggin Hill were awarded the military medal, 3 of only 6 in the whole of the war, for holding to their posts under fire when Biggin Hill became the centre of a Luftwaffe attack. One such WAAF, Elizabeth Mortimer, was serving at Biggin Hill. She was operating the telephones and came under direct fire on the night of the 31st of August into the 1st of September in particular, and she held to her post. And then, having finished her shift, she decided that in order to warn the returning aircrew that there might be unexploded bombs, she would run around the airfield, finding where she thought those unexploded bombs might be and marking the sites with a red flag. At one point, a bomb exploded so close to her that she was blown off her feet and actually remained deaf in one ear pretty much for the rest of her life. But she got up, dusted herself down and continued planting her red flags, putting to bed the idea that women might buckle under pressure or not be sufficiently brave to work in this sort of context.
Biggin Hill was one of the first targets in the Luftwaffe raids. Between August 1940 and January 1941, the airfield was attacked 12 times, destroying barracks and workshops and killing 39 people.
We did see a real revolution, albeit a small and ongoing revolution, if you like, in the way that women were perceived as a result of the way in which they played their part in this room and others around the country, doing these sorts of roles at a time when there was simply nothing else to be done but to get on with it.
While the ground crews were busy patching up the heavily damaged airfields, the pilots were trying to shoot down as many enemy bombers as possible before they reached the targets. But whether you were flying a Spitfire or a Hurricane, you were completely reliant on the 8 303 Browning machine guns that each aircraft carried. But just how effective were they? Well, I've come here to this rather spooky facility to find out. Dave.
Jules.
Hello, mate. This is an extraordinary place. I was told I'd find you in here, but it's a labyrinth.
It is, yeah, it's quite a big complex.
And you've got the facilities to test more or less any kind of weapon.
Yeah, we certainly test a lot of small arms here anyway.
And that's the range. How long is that?
The range is over 200 metres long.
Wow. Now, what have we got at the end of it?
At the end of the range, you can see Messerschmitt armour. It's a representation of 5mm, 8mm and 12mm armour. 5mm on the wing spars, 8mm on the pilot protection area, and then 12mm on the bulkhead.
Now, we've got two fascinating looking weapons here. That I recognise as a Bren gun.
Yep.
303?
Yes.
What are we going to do with that?
The Bren gun's going to stand in for the 303 aircraft, because the problem with the Browning 303 aircraft machine gun is it's air operated, fired remotely with a trigger on the control column of the spay grip. And so, to make life easier, we're going to set it up in a tripod.
And next to it, you've got a 50 calibre Browning.
During the war, all our 50 calibre Brownings that we actually placed on the latter Spitfires, they were all manufactured in the US.
And I suppose in many ways, any student of the Battle of Britain will recognise that the 303 Browning was a key component, but just how good was it?
It was a very good, reliable machine gun. From the early days when they ironed out the development from the American one and made the British Browning machine gun, it was very, very good. Its only problem was the Germans are up-armoured and they'd already got a more powerful machine gun in their own aircraft, and that was its limitation.
So was the Messerschmitt 110 better armed than a Spitfire or a Hurricane during the Battle of Britain?
It was, yeah. It was better armed. The pilot had better armour, and the aircraft overall had more armour than the Spitfire, or the Hurricane for that matter. So, really and truly, the 303 really had to do a lot of work, whereas the German aircraft, with their cannons and machine gun, had to do a lot less.
So the idea is to see whether or not the 303 can get through any or all of those armour.
That's right, yeah.
How many rounds have we got?
We've got quite a few.
Excellent. Well, this will be a really interesting test to see how effective it was.
With a tracer element at this range, we should see some good tracer element going down.
Right then. Let's see how our Bren gun fares. Right, where's your helmet?
So here.
Gun is cocked and live.
It's ready to go, Jules. Yeah.
Okay.
So you just get behind it.
Okay.
Okay.
I'm ready to fire.
In your own time, go on.
Oh, there's certainly a little spark at the end. Oh, yeah.
Yeah, that's one.
That's certainly hit.
Yep. Yeah, that's good. And keep going at that, Jules.
Round's complete. Dave, absolutely fascinating.
Well done, you hit the target.
There's not a huge kick off that. You get the sense that there isn't a lot of weight behind the round.
Well, let's try something different. Let's try the 50 calibre machine gun.
Now, I'm used to seeing these mounted on the top of tanks or indeed in the wastes of flying fortresses and that sort of thing.
Absolutely. It was absolutely completely universal. The US Navy had them, the Air Force had them, they had them on tanks, they had them in the infantry role.
Yep.
And it's still in use today.
And this is the ammunition?
That's the ammunition. Now, if you compare that ammunition, that's exactly the same as it was at wartime. And this is the 303. So you're now looking at the size of that round compared to that round.
Yeah.
So when we put an explosive charge in the head, it's far more effective.
I never thought the day would ever come when I'd get the chance to actually fire a live 50 calibre. But today is my lucky day, Dave.
Today's your lucky day.
Right. Let's have a look and see what it does to the armour plate.
OK, Jules, I'm just going to let the working parts forward, get it ready to load.
OK.
OK, so we'll just let the working parts forward, lock it off, and then what we're going to do is Matt will assist in the loading, I'll assist in watching where the rounds are going and making any adjustments we need to make. OK, load.
And to think this is a 1945 wartime dated weapon.
It is, yeah, absolutely. Goggles?
Thank you very much. Right.
OK, so we're going to cock it underhand. Yep.
Ah, got
there
it.
There you go. OK, we're now loaded and we're now ready to fire.
Short bursts?
Short bursts, yep, absolutely.
Okay, here we go then.
And again.
That is a thump.
That is a thump. You've just taken over the targets.
Most of the targets?
Destroyed.
I think, is there one left on the right?
Yes, there is.
I think that cloud of smoke means we've got it.
Let's go and see what you actually have done.
It'd be fascinating to see, won't it? But you get a real idea of the power of this weapon. I mean, that's a real thump, a real thud coming right through your body.
You can feel the shockwave. You could actually feel it in the aircraft when you were firing the cannon in the 50 calibre.
That's incredible. And of course, here we are in the confines of this concrete range. The pressure wave, the shock wave, feels all the more. Right then. Let's go and have a look. Wow. So this is still standing. That's rather disappointing, isn't it? Look at that. You can certainly see the 50 calibre hole.
Absolutely, yeah. You can actually see that quite clearly. If you look at that, you can really put your finger clearly through there. And you see the ones at the top. This is the tracer rounds that we had in there.
This is the 303 round.
This is the 303, and that's obviously the tracer round, which is a lighter round. And there you go. There's your armour piercing. So it's penetrated the wing spar armour. And certainly penetrated the wing spar armour with a 50 calibre.
There's absolutely no arguing with that.
No.
Is that the thickest plate?
This is the thickest plate. So, you know, we can see that there. It's just riddled with holes all the way through it. This is 12mm of frontal armour. So you can see there, that is gone all the way through, no problem at all.
I mean, never mind an aircraft, you can see what it would do to a lightly armoured tank as well.
Yeah.
You know, it's interesting, you read about this stuff, you study it, you talk to veterans, but when you see it for yourself firsthand, it's devastating, it's terrifying.
Shocking. It's absolutely shocking. And remember, all these holes come through, bits come flying off, you then got fragments and shards flying through the aircraft. You know, hundreds of miles an hour. Fingers?
Yeah. There it goes. Well, Dave, it's been an amazing day, a really fascinating insight into just what these pilots were up against, and importantly, what they were armed with and how the battle began to turn in our favour.
Yeah, it's amazing, isn't it, to see how it all went round.
It really is. What a place. I'm glad I wasn't the other end of one of those, I can tell you.
Absolutely.
You know, much of wartime Biggin Hill has sadly disappeared, but this is a rare survivor. It's the original dispersal hut that pilots would have gathered in and around, playing cards, reading the paper, trying to relax as they waited for the call to scramble. And you have to wonder if they were listening to the radio here on the 20th of August 1940 when Churchill, speaking in the Commons, uttered those now immortal words.
Never in the field of human conflict was so much owed by so many to so few.
He was, of course, talking about them. At the time Churchill made that speech, the battle was still raging and nowhere near won.
We're on the ridge where the observer post and a couple of guns were placed. The airfield is now through the trees. This, of course, was generally an open area opposite to the airfield. When I was a lad, this is where we came through and continued on further, and the position would have been somewhere just along on this ridge here. I'd managed to get into this area, which of course was very much an area that people were not allowed to come into, and it gave me the opportunity to see something which was really quite exceptional, I suppose. I didn't think that much of it in those days, but nowadays one would realise that you were in the front line of what was going on. The German aircraft appeared coming from the southeast, and they started then to bomb the airfield. I didn't feel frightened to any great extent. It was excitement at what was happening. This was boys' own stuff at its best, but of course it was a desperate time. And I think as the months rolled on and the Blitz started and we were bombed out of our house, 3 times they came along and repaired it, and 3 times we had to leave. You realise this wasn't just a game.
Both sides suffered heavy losses during the Battle of Britain. In just 17 weeks, nearly 1,900 Luftwaffe planes were destroyed, with over 2,600 casualties. The RAF lost over 1,100 aircraft and suffered over 800 casualties.
I got told off time and time again, but it was too exciting not to watch what was going on. But of course we were winning, you see, and when you saw a German aircraft fall away, you didn't think of the people who were in it, you just thought that's one less, and we were winning. We didn't realise the importance of Biggin Hill at that time, because Biggin Hill was really the last line of defence before London, and the aircraft from Biggin Hill were the ones that had to defend virtually London, and so it was a place of great significance.
The RAF's success in the Battle of Britain was indeed a turning point during the dark days of 1940. But it had given Hitler his first taste of defeat, and importantly, had provided Britain and her allies with a real sense of hope. But however welcome that victory, it had been bought at enormous personal cost. Biggin Hill was given the nickname the strongest link for the role it played. However, countless others also did their part in thwarting the invasion. The Royal Observer Corps, the women of the WAAF, the Blenheim bombers who destroyed the invasion barges, to name but a few. The chapel at Biggin Hill holds many memories. This case contains Biggin Hill's Book of Remembrance, and it's inscribed with the names of all 454 aircrew who lost their lives throughout the war flying from here. It's currently opened on the 19th of July 1940, and it records the fate of too many of 141 Squadron who flew Defiance during the Battle of Britain. Their rate of attrition was so high, following this day, the squadron pretty much ceased to exist. But every day, since the end of the war, a new page has turned, helping us to remember all of those who flew from here. Well, this is known as St George's Room here at the chapel at Biggin Hill, and it commemorates in these stained glass windows the ground crews that the pilots held in such high regard. This one is dedicated to ground control. Here we've got the WAAFs leaning over a plotting table with a map of the south coast, and above them their controllers. And in these little panes, the radar masts, that key component that really helped in the Battle of Britain. And this one is dedicated to aircraft servicing. Ground crews, their aircraft and their pilots often had a very close relationship. Here we've got a crew working hard to keep this particular Spitfire in the air. Looks over
under the careful eye of a sergeant. And then this one is dedicated to those who packed the parachutes. These really were people you'd want to depend on. You survived one of the riskiest jobs that the war could offer any young man. How did you do it?
I thank God, I suppose. I can't really say much more than that. Fortune was on your side, and you were very lucky, and you pick out fleeting glances, I think is the best way I can describe it. And sometimes it's the consequence of those fleeting glances which sticks in your mind. There are fleeting moments, and it all happens very quickly.
You visit the chapel here at Biggin Hill regularly, Rodney. What does it mean to you?
I would hate to miss it, and obviously the day will come when I'll no longer be alive to enjoy it. But all the while I am, and I'm now 92 years of age, I'm very lucky to be able to enjoy it.
As 1940 developed, the fighter pilots came into their own in the public consciousness because of the Battle of Britain. And for all the horrors and dangers they faced, their life was often portrayed as glamorous. Did you ever see that? Did you ever recognise that? Did it inspire you?
I wouldn't see it as a glamour position. I would see it as a worthwhile position that you were able to do something and you were not completely lost.
The Battle of Britain was the first major campaign to be fought entirely in the air. The conflict raged over southern England for 3 months, involving over 2,900 RAF aircrew. It was the first Allied turning point of the Second World War and a defining moment in world history. The German plan to beat the RAF had failed, and so too had the invasion of Great Britain.
You know, for many people, as an airfield, Biggin Hill is hallowed ground. Throughout the war, its squadrons and its pilots of all nationalities that were based here destroyed over 1,000 enemy aircraft. Its personnel collected over 200 awards for gallantry and skill in combat, but it is perhaps that summer of 1940 and its role in the Battle of Britain itself that has enshrined its place in the history books.
The gratitude of every home in our island, in our empire, and indeed throughout the world, except in the abodes of the guilty, goes out to the British airmen who, undaunted by odds, unwearied in their constant challenge and mortal danger, are turning the tide of the world war by their prowess and by their devotion.
For over a century, the legendary tales that have surrounded our great British airfields have inspired generations of people, including me, which is why I am on a personal mission to cross the UK to visit some of our most important airfields, to understand not just about their contribution to our past, but importantly, how many of them have helped define our future. From the UK's first flight, through to groundbreaking innovations such as carbon fibre and the jet engine, and the extraordinary effort spent on preserving our aviation heritage. Join me as I explore the story of the airfields that have helped shape Britain and the world. Duxford Aerodrome is one of the best preserved airfields in Britain. With its historic buildings and hangars full to the brim with beautifully preserved aircraft, this is a place where history isn't just alive and kicking, it's flying.
Abandoned in the early 1960s, Duxford was brought back to life in 1977 when the Imperial War Museum, known as the IWM, took control. It's now home to an impressive collection of aircraft, vehicles, weapons and artefacts from different countries spanning over 100 years of history. Duxford is, of course, of huge historical significance in its own right. Throughout the Second World War, it was a key airbase and was home not just to some of Britain's most famous fighter races, but also to the US 8th Air Force. If, like me, you have a passion for planes, this is the place to come. Peter, very nice to see you.
Yes, good morning. Welcome to IWM Duxford.
Peter, no trip to Duxford is ever wasted. I guess for many people they associate it with World War II, but its history is much older than that.
Oh yes, happily one of our claims to fame is that we're actually a superb preserved example of a First World War RAF station.
The site is dominated by these enormous hangars. When do these date from?
Yes indeed, construction of the three big surviving historic hangars actually began in October 1917, and one example you can see straight away adjacent to the hangar behind us is the First World War flight hut, which was extended during the 1920s to incorporate the watch office.
And what aircraft were those early squadrons that were based here equipped with?
The three squadrons that were mobilised from here were equipped with Air Cody Havilland DH6 and DH9 biplanes. But the main purpose of Duxford was as a training depot station. And we have 4 preserved examples of appropriate types on site here. And if you'd care to join me, I'd be delighted to show you a couple.
I knew you'd have plenty.
This is one of the 4 aeroplane types that the IWM has preserved, which date from the First World War. This is a Royal Aircraft Factory BE-2C, which were used on the Western Front for reconnaissance, artillery spotting and light bombing. Now, unfortunately, it was such a stable aeroplane that it turned out to be unsuitable.
Too much of a target.
For Western Front operations, yeah. It couldn't manoeuvre in the face of enemy fighters, so it had to be withdrawn.
It's an incredibly rare survivor, isn't it?
Mm.
But not to take away from the aircraft, Peter, the building we're in is absolutely beautiful, and of course it's dominated by these incredible lattice beams, I suppose.
The lattice work construction is very impressive. It's very eye-catching. The design term is Belfast Truss. You can tell how durable it is simply because of the age of the buildings and the fact that the structure has survived some very stormy weather.
The buildings here, these hangars, are, I suppose, the jewel in Duxford's crown in many respects. But of course it wasn't just about hangars. A huge array of ancillary buildings stretch out all around us. Can we go and take a closer look at some of those?
Yes, let's go and have a look at some of the stores and workshops. So along the road behind us, the green buildings were First World War storerooms, clothing stores, technical stores of different types.
And what's this one with 1918 written on it?
Yes, what looks like a chimney, it's actually a fume extractor, because this was one of the most important of the First World War workshops. It was the fabric shop where they did the doping, because they had to have a way of getting the fumes away from the chaps and the girls working.
Well, the dope workshop was an infamous place to be, wasn't it?
The hazard was recognised, and one of the counters, for example, was that the staff were given an extra milk ration. Yes, so we're now approaching the front entrance to the officers' mess.
It looks rather forlorn now with all the leaves, but it must have been a very sumptuous building.
Yes, indeed. They deliberately tried to make the accommodations and facilities as comfortable as possible, and it's quite impressive. I can give you an illustration. This is actually a very poignant photograph. It shows one of the anterooms, so you can see the windows behind
The windows
us.
are a real giveaway, aren't they?
Yeah, and this is actually some of the station personnel, RAF and Army liaison officers, listening to the declaration of war, the announcement over the radio by the Prime Minister.
I mean, the life of a fighter pilot was one of great contrast, wasn't it, Peter? From being up there engaging the enemy to then landing and enjoying the relative comforts of a mess like this.
It was a very important morale factor.
And I'm kind of rather moved by the fact that the greats kind of inhabited this building, the likes of Barder and others.
Yes, indeed, and happily we can prove it. There's, if you take a look at this photograph, here's Sir Douglas as he later became, with 2 of his fellow pilots here in 1940 during the period of the Battle of Britain.
I think when you can place yourself in a moment in time like this with a photograph such as that one,
outside of building that has the pedigree and provenance that this one does at Duxford. It's quite moving, isn't it?
Oh, very much so.
Sir Douglas Bader was perhaps one of the most legendary of Britain's World War II fighter aces, credited with 23 aerial victories. He joined the RAF in 1928, but famously lost his legs in a plane accident in 1931. Although able to fly with artificial legs, he was retired from the RAF against his will. Only with the onset of war in 1939 was he able to rejoin as a pilot.
He convinced people at the Air Ministry that he should be allowed back into the RAF as a pilot. And he came back to fly successfully, not just as a fighter pilot, but as a very successful fighter pilot, and as a squadron leader, and then leading a whole group of different fighters from this station during the Battle of Britain.
In 1940, during the early stages of the Battle of Britain, Fighter Command was outnumbered in aerial combat. So to conquer this, the Big Wing was formed. It consisted of 3 to 5 squadrons, made up of nearly 60 aircraft in diamond formations. It was thought the more fighters involved intercepting the enemy, the more aircraft they could destroy. Bader was a champion of this aggressive idea.
On the 15th of September, when the Duxford Wing, or Big Wing as it became known, was involved in combat against the German formations twice on that day, what it did do was certainly persuade the Luftwaffe that the British Air Force wasn't defeated by any means. So if only from the morale point of view, Bader's Big Wing had a big impact on the Germans. So although Bader was the most famous character connected with Duxford, there are many other pilots here. At any one time there were between 60 to 80 pilots here. Anyone from Bader through to George Unwin to Brian Lane, who was the commanding officer of 19th Squadron. In a sense, the successful aces were the few of the few, but those are the guys that did most of the shooting down of the enemy aircraft, but they're supported by other fighter pilots who are up there maybe protecting their back in combat.
Duxford was home to 15 squadrons with pilots drawn from all over the world. From Canadians to Czechoslovakians to the Polish who had escaped the German invasion.
So we're standing inside the operations room at RAF Duxford. It's a reconstruction of the room inside the original building. So each airfield had its squadrons ready to go, and if there was an enemy raid coming in, the operations room at Duxford would be told to get a squadron up in the air. So the controller, who sat on the dais behind me here, he could see where the enemy formations were coming in on the big map table. The squadrons would be called to basically scramble, get in the air, get off as fast as they could to intercept the enemy formations. I interviewed one of the guys who actually worked in these little radio cabins here. He said, one day Bader's message just consisted of 6 F words. Some of his language was notorious, shouting back to Woodall like my eyes are standing out like dog's bollocks, but I still can't see them, Woody, where are they? That sort of thing, Obviously the blokes were under real stress. They were being shot up in the sky, so things were pretty tense.
Unlike the Hollywood films we see today depicting aerial dogfights, in real life combat would only last a matter of minutes. A Spitfire or Hurricane could fire off all of their rounds in just 15 seconds.
You wouldn't fly straight and level for more than 30 seconds because you're always afraid that someone's going to get on your tail. You're focusing on trying to hit your enemy. Could have been a big target, a small target, but if you got into combat with an enemy fighter, then you're pulling really sharp turns, sharp Gs. You might even black out as you're doing a fast turn. Maybe, this often happens when I'm told, when you're in combat, that you can end up in a completely empty sky. There's no one else there at all, and it's all dissipated, it's all gone, and then you're calling back to the operations room for a fix to fly back to your home base.
Duxford's RAF pilots played a critical role during the war. Every day, on average, 60 Spitfires and Hurricanes were dispersed around the base.
The collections here at Duxford are unrivalled, and this is one object that I think speaks volumes. This is Douglas Bader's uniform, complete with medal ribbons, including, of course, the Distinguished Flying Cross. And it's that level of detail here, that access to the men behind the machines, that really do make this place come alive.
Today, Duxford's main role is in preserving our aviation history. Everything from photographs to buildings to aircraft.
Now, not all items here at Duxford arrive in pristine working condition. Many have to be lovingly and painstakingly restored, and that happens over here. Wow, this is amazing. If you're interested in aircraft restoration, James, this really is an Aladdin's cave, isn't it?
Yes, this is the Aircraft Restoration Company. We look after a fleet of around 40 historic aircraft, ranging from the P-51 Mustang, which is the Americans' finest fighter of the time.
But what a place. I mean, everything that comes in and out of your doors flies.
Yeah, every single aeroplane we maintain, operates and or restore will end up flying from here.
And do you only deal with propeller-driven aircraft?
No, not only propeller-driven aircraft, we also look after vintage jets, one of which is the F-86 Sabre A model, which is in the hangar at the moment. It's the oldest flying jet in the world currently.
But the range of skills you have to master, from jet propulsion to propellers to varying types of airframe and materials, it's an enormous challenge.
Yes, it is. It's huge, which is why we've started our own apprenticeship scheme, as there are no longer the skills around in this country for us to keep these aircraft flying.
But just as an example, how many hours would it take a year to keep, say, that beautiful P-51 Mustang in the air?
You'd be looking at around about 6 to 8 weeks of maintenance by a team of engineers, around about 4 or 5 weeks in the winter, and then a couple of weeks in the summer for oil changes and that sort of thing.
But I gather that you don't just maintain and restore them, you also build a good number from scratch.
Yes, we do.
Let's have a look at that. As well as being a museum, Duxford is home to around 20 to 30 historical aircraft that are still flying. From Supermarine Spitfires to the huge B-17 bomber, the Sally B. Mo, nice to see you. I gather if anybody knows how to build a Spitfire, it's you.
Apparently so.
Thank you very much, James. Cheers. Mo, this is astonishing. Is this a completely new wing?
No, this wing is for a Mark 11 Spitfire, and we recovered approximately 25% of the original parts.
So having that tiny percentage of an original is enough to give the finished aircraft the right sort of provenance?
That's right, yeah. Yeah, 25% these days is a lot to have, yeah.
But just looking at this table in front of me, these all look like brand new components.
This is a new side cowling. Quite often the side cowlings don't exist with a project. They're things that get taken off and lost. So most of the time they're made as a completely new item.
Can you give me an example of one of those skills that you've had to sort of relearn, as it were?
Yeah, one of the main ones is wheeling, and I can show you a good example of that over here. Now this leading edge skin here is, because it's a double curved shape, you can't just roll it in one direction. You need to wheel it to shrink and stretch the material.
You say wheel it, actually put a wheel over it?
It's nipped between two wheels, and that stretches the materials in different directions.
Because that is a really iconic bit of the Spitfire.
That's right.
This wonderful elliptical shape. I mean, there isn't really a straight line on it.
No, and that poses the problem for shaping the material.
The satisfaction you and your guys must get from seeing an aircraft 18 months later roll out of the hangar onto the runway and get airborne.
Yeah, it's great. You've seen the project from birth to end, and then you know it's going to go flying around the country for people to enjoy.
During the 1930s and 40s, over 20,000 Spitfires were built. Today, through restoration and preservation, there are around 28 still flying in the UK and over 50 worldwide. Well, Duxford was the first fighter airfield to take delivery of this, the now legendary Spitfire. And it's also a first for me, because I've got my chance, at long last, to get airborne in one with lovely Cliff. Good to see you, mate.
And you.
I cannot tell you how excited I am to finally get my chance to experience what this beautiful aircraft is all about in its natural environment up there.
Well, you've picked a right day.
Haven't we just?
Yeah.
Blue skies.
Blue sky, everything's going for us.
No wind. And this.
Yeah.
Now tell us a little more about this particular aircraft, Cliff.
It's quite a famous Spitfire. All Spitfires are famous, but this one was built in 1944 and actually flew at D-Day. And it's got 4 victories to its credit. So you're flying in quite an important aeroplane. In those days, of course, it was a single-seater, and it's converted after the war into a 2-seater, which is good for you, because I'm not sure you could go solo on your first trip.
It's my chance to finally do it, but how astonishing that this aircraft saw D-Day. It saw that great armada assembling off the Normandy beaches.
Absolutely, absolutely did. And indeed, it's painted in the colours that it was at that time in 1944.
So if I were to take to the skies in a Spitfire, this arguably is the one to do it in.
Absolutely.
Well, Cliff, I've got you to fly me. We've got this incredible aircraft. We've got the most stunning blue sky above us. Should we get on and get up?
Let's go and do it.
I am too excited.
Right, there you go.
And lower myself down.
Yep. All right.
Okay.
Okay, elbow through there. And we'll do the same with the other side. Just pull those apart and slide it over the head.
Good stuff.
Good stuff. Well done, well done.
See you at the other end?
Yeah, right.
Well, I am strapped in. My parachute is on under my backside. And we are about to get airborne. This really is a dream come true, a flight in a genuine World War II Spitfire. Let's go. What a wonderful noise.
Yes, isn't it a lovely noise? It 27 litres, Rolls-Royce Merlin, 60 series, 1600 horsepower.
Unbelievable. Oh, God. I'm actually on the motor. That is not. Like most kids, I was hugely inspired by the Battle of Britain. And to see it from the air, from a Spitfire. Look at that. And of course, these aircraft would have been scrambled in seconds and then directed to the enemy by the incredible work of the ground controllers relying so heavily on radar. But imagine it, Cliff, taking off on a day like this when you can see almost nothing else in the sky but knowing the enemy, the bandits, are out there somewhere. Absolutely. 20 pilots talk of the aircraft being an extension of themselves. I can absolutely see what they meant. I feel like I have sprouted wings as Cliff brings us in over the airfield at over 200 knots. There we go. And up into a climb. And back to the left, and then the airfield and bumping. Oh, beautiful, beautiful. Up, up, up. There we are. Oh, the grace of this aircraft has to be felt to be believed. There we go. And we're done. Yes, yes, yes. Well, I've been coming to this airfield ever since I was a boy. I've watched the museum develop and grow. I never really thought I would ever get the chance to see it from the air or to see it from a Spitfire. But today really has been my lucky day. Cliff, thank you. Thank you very much indeed.
Before operational bases like Duxford received their Spitfires, the pilots would need tuition, and this happened at training bases. But with most of the men at war, the role of maintaining the aircraft was left to the Women's Auxiliary Air Force. They weren't allowed to go into combat, but they did fulfill many ground crew roles, from radar to engineering.
The men had all been sent off to operational stations, and the ones that weren't operational were getting short of mechanics. That's when they made the girls mechanics. When a pilot had done so many hours flying, operational flying, he had to come and have a sort of break and a retrain. And that's when we looked after the aircraft, and every time they flew we did a quick inspection where we changed the wheels and we did everything more or less the outside of the aircraft. screwed things on and screwed things off and one thing and another. But when the pilot had to take it for a test flight and he had the engines going, two of us had to sit on the tail of the Spitfire because with the thrust of the props going round, it would have tipped up. So we used to sit on the tail until we turned into the runway, then you jumped off. Well, one girl didn't jump off. She was lying across the tail and got airborne. And when the pilot wanted to bank, or which is turned, he couldn't, because what they call the ailerons wouldn't work. So he had to get a emergency landing. And when he got landed, and this girl jumped off, the poor man was he was terrified, he thought he'd killed her.
By July 1943, the Women's Auxiliary Air Force had swelled to around 182,000, serving in over 110 different trades. The Supermarine Spitfire wasn't the only star to be based at Duxford. In 1943, the aerodrome was assigned to the United States Army Air Force, the USAAF, and it became known as Station 357. Within a few weeks of the Americans moving in, Duxford became a showcase for the 8th Air Force, with plenty of famous visitors.
Well, what better place to dive into the archive, Carl, than here at Duxford Cinema? This is incredible footage. When did the Americans arrive here?
The Americans arrived here in April 1943. You can see it on the footage there. This is shortly after they arrived when the King and Queen visited. And they very quickly sort of made Duxford their home. You know, they very quickly changed the atmosphere. I suppose changed the atmosphere of the whole region, because you can't just plonk 2,000 guys down in the middle of the Cambridgeshire countryside for them to not have an effect.
For many people, Duxford is synonymous with the Battle of Britain, and the American involvement here is perhaps a little bit unappreciated.
That's right, and if you think about it in terms of the overall conduct of the war, Britain is on the defensive in 1940. It's very much a defensive effort, and Duxford is part of that defensive effort. But then when the Americans arrive, that very much signals that the war is going on the offensive, and of course that's what they're there to do. They're there to take part in that strategic bombing offensive.
But I suppose they bring with them a great sense of optimism. Britain's been at war for several years, it's feeling the strain, and yet here come these new, young, fit, fresh-faced boys who are keen to re-energise the fight.
There's a lot in that. I think particularly Britain had been at war for quite a long time. It was a bit war-weary, it was a bit shabby, and you know, these guys were coming over with an enormous amount of economic might. They could build 12,000 B-17s, build the fighters.
But they also clearly bring a real sense of glamour and exoticism to Cambridgeshire.
They brought a real sense of glamour, of otherworldliness. You know, it was called a friendly invasion, and there are two parts to that. Yes, it was friendly, but I guess for a lot of people it did feel like an invasion, because all of these people from a completely different culture were suddenly descending and having to mix and having to exchange their cultures in quite a sort of intensive way.
But also a tide of celebrities to go with it.
Absolutely. So not only did many of them sound like film stars, some of them were actually film stars. So people like Clark Gable, Jimmy Stewart, all doing their bit, you know. And then of course you had celebrities who were deliberately flown over to entertain the troops. So people like Bob Hope, people like Bing Crosby.
But I'm reminded of that great phrase that emerged from the American invasion, if you will, of them being overpaid, oversexed, and over here.
I think one of the most interesting responses I saw to that was an American who said that the Brits were underpaid, undersexed, and under Eisenhower.
Yes, of course.
To pay tribute to the 30,000 American airmen who gave their lives flying from UK bases, the American Air Museum was opened at Duxford. It's home to an impressive array of American aircraft from World War II to modern day.
This beautiful purpose-built American hangar here at Duxford is packed with examples of the aircraft the Americans produced. That's a B-17. Above me, the tail fin of a Marauder. Up there, a C-47 Dakota. The whole thing is dominated by this enormous B-52, but it also contains examples of two of the aircraft that the USAF brought here in April 1943. The P-47 Thunderbolt, and over there, the P-51 Mustang. And of course, with the planes came the pilots.
One of these pilots was Huey Lamb of the 82nd Fighter Squadron. He amassed over 200 hours of combat flying, destroying 5 enemy aircraft in 61 missions. Originally from Texas, he found the British climate difficult to get used to.
We'd been on the Queen Mary for a week or two, and I hadn't had a freshwater shower. So I took a shower, and it was ice cold. And then after that, I never got warm while I was over here. It was chilly.
When Lamb's 78th Fighter Group initially moved to Duxford, they brought with them the largest and heaviest fighter in history to be powered by a single engine, the P-47 Thunderbolt. When fully loaded with its 8 machine guns and bombs, the P-47 weighed a staggering 8 tons.
When we got over here, we had a different opinion of the P-47, and the reason was that they used 100 octane gas here, and when we were training, they used 80 octane. So it made that much difference. It's just amazing how much difference, and we really respected the ability of the P-47. And we also had a very good high-altitude airplane with a big supercharger and an excellent low-altitude airplane for strafing and ground work.
In 1944, Lamb made history as only the 3rd 78th Fighter Group pilot to down the world's first operational jet-powered fighter, a German Messerschmitt 262. The kill took place during one of many low-level strafing missions, and although they were effective in destroying enemy targets, they also made the attacking aircraft vulnerable from the ground.
You know, it's hard to imagine, but most of the people that were in our outfit wanted the dangerous missions. January, February of '45, we got a new CO, Colonel Gray, and he went up to headquarters and he said, I'm gonna get you guys some good missions. That meant get some action. And so we got some good missions after that.
In December 1944, the 82nd Fighter Squadron were fitted out with new fighters, the P-51 Mustang. Lamb flew 2 Mustangs, both named Etta Jane after his little sister. The first one, however, didn't survive the war. On his very first mission out, the aircraft suffered an engine fire, forcing him to ditch it into the freezing North Sea.
I thought I was going to make it to the shore at Orford Ness. About 3 miles off of there, you'll find Etta Jane the First. It's about 100 feet down in the ocean there. My right wing stalled and caught a wave, and it cartwheeled, and that saved me. Because if I'd have landed straight, there's a scoop underneath the P-51 that would have brought it straight down. And I was also fortunate that I had people that saw it go in, and then my wingman, his radio was out, and I was bringing him back when this happened, and he flew and saw a walrus taxiing out, and he landed, set the brakes, and told them that he had a man down and he'd lead them to me. It was, you know, it didn't fly very fast, and he would circle and then head out, and then circle and head out. And then they landed and picked me up. I didn't know it, but they had 6 attempts to start their engine. And they finally got it started. So I've been lucky all along. You know, everybody needs luck.
Today, Huey Lamb has returned to Duxford and the American Air Museum. He's here for the unveiling of a brand new museum exhibit.
The reason I'm here for this visit is they have restored a P-51 and put the markings identical to Etta Jane II, the plane I flew in combat here. Everything just as it was. And that's the reason I'm back here to see it. Well, naturally, it makes me want to fly. Fly it, period.
By 1944, the United States Army Air Force had deployed some 450,000 Americans to Britain. And with only 7% of those being pilots, the majority were ground crew. The American invasion that had swept across Britain, filling the country with thousands of young men, brought with it the possibility for tension. And in a bid to try and iron it out, the American authorities issued their troops with this: Instructions for American Servicemen in Britain, 1942.
Now, the book is pretty simple, but its message was vitally important, and it begins with this. You're going to Great Britain as part of an Allied offensive to meet Hitler and beat him on his own ground, but for the time being, you will be Britain's guest. And it reminds the American that Britain may look a little shop-worn and grimy to you. The British people are anxious to have you know that you're not seeing their country at its best. There's been a war on since 1939. But it's also quite amusing. I love this one. The British don't know how to make a good cup of coffee. You don't know how to make a good cup of tea. It's an even swap. And so it goes on. It is always impolite to criticise your hosts. It is militarily stupid to criticise your allies. And that was what it was all about. If the Allied cause could not be united at every level, it would never stand any chance of success. During the period of World War II, about 2 million Americans would pass through Britain. Many would be stationed in East Anglia, where they became a common sight, flooding the nearby towns during their time off.
During the war, Cambridge was very much a social hub for the American GIs and airmen stationed around air bases in East Anglia. Behind me here we have the Bull Hotel, as it was, which was converted by the American Red Cross. The Red Cross clubs were really providing a home away from home for the Americans. They could read magazines and newspapers that had been shipped in from the United States. They listened to American music on the jukebox, and there was plenty of Coca-Cola, coffee and donuts on hand to really make them feel at home. But the one thing the Red Cross clubs didn't have is alcohol. They weren't licensed, so the GIs would have to go to the local pubs if they wanted to get a drink. And in Cambridge, that meant a trip to the Eagle.
Already popular with RAF aircrews, the American servicemen continued the tradition of inscribing the numbers of their flight squadrons on the ceiling of the Eagle. Using lighters, candles and lipstick, the Americans left their mark, but it was their personalities that left a stronger impression.
When the Americans first arrived, there was a certain degree of suspicion about them coming from the British people. Often they felt that they didn't look like an army in the way that they expected them to. They didn't march quite as rigidly as the British men. Partly this was because the Brits only saw the Americans when they were off duty, you know, when they were out having a good time. And often there was this kind of idea that, are these really the people who are going to save us? They don't seem up to the job. The British women, for the most part, came to really appreciate the Americans. They had a real allure. Partly this was because for British girls, mostly they'd never seen an American in their life apart from at the cinema. So when the GIs came over, they had this aura of Hollywood glamour attached to them.
The first time I ever saw the Americans were the time when my friends and I came out of the dance and we heard the wolf whistle and wondered, who are these people in these uniforms? We had never seen them before. They were very handsome and nice manners, and they smelled nice too. They had lovely cologne on, which our poor guys, I feel sorry for them because I had a brother in the army. They weren't able to get all this stuff.
The Americans were advised not to brag too much to the local people, or not to swank, as they called it at the time. But in fact, a lot of them did. One woman actually married an American guy who had told her that he was in oil, but when she got over to the United States, it turned out that he was a gas pump attendant.
The American salaries were more than 5 times that paid to British troops, making their generosity particularly attractive to women. Around 70,000 British women became GI brides, and around 9,000 babies were born out of wedlock as a result of British-American liaisons.
The first American that I knew, and I was so fond of him. And can I read this for you? If I can get through it. It always makes me a little bit teary, but never mind. He was 22 and I was 17. I thought he was lovely and he seemed very keen. But he was a bomber pilot, didn't stand a chance when singled out by fighters shot down over France. That evening, as usual, I waited. His friend came instead. I sobbed as he told me my lovely friend was dead. Since then I've loved a dozen times, but first love so sincere. Remember him? Of course I do, especially this time of the year. So that was the first time that anything like that really hit me. But it happened you'd have a date, and your date wouldn't turn up, and somebody else would say, oh, he didn't come back from such and such, and you'd think, I can't be doing with this, I just can't.
Betty met a number of Americans, and at a dance, one particular GI took a liking to her.
He would call me, and we'd meet in London and dance again, as you do, at the Palais or wherever it was, and have a lovely time. And then one day, after the war had been over, he phoned me up and he said, would you marry me? It was a bit of a shock. I hadn't thought about getting married, I must admit. It wasn't something in my diary for the next day or week or month. Besides, I was still hankering after my soldier that had gone overseas. Anyway, not to worry.
When the GIs left, they left a real void for many of the British people who'd grown used to them being around. They'd grown used to these cheery personalities, to their charm and their wit and their good manners, and they really missed them.
Just a month after the end of the war, in October 1945, the Americans left Duxford and the base was returned to the RAF. But by 1961, Duxford was deemed too far south and too far inland to be of any strategic value, and it was abandoned. In 1977, the Imperial War Museum gave the site a new lease of life. The museum needed a bigger site outside of London to exhibit their larger displays and house their conservation workshops. These workshops are one of my favourite parts of the museum here at Duxford because their contents change year upon year, month upon month. You never quite know what you're going to find. Take this, for example. This field gun is the field gun that fired the first British round during the First World War. They've just cleaned it up. This is the front end of a Handley Page Halifax. And next to it, a post-war Spanish-built Heinkel. This one starred in the movie The Battle of Britain. But take a look over here. This is extraordinary. This is the fuselage of the Messerschmitt that Rudolf Hess was flying when he landed in Scotland and was captured. But of course, it's not just the old stuff they deal with here. You'd be surprised at some of the new material that's coming through every day. This is perhaps my favourite part of the museum. You get to see all the jewels in the collection passing through here at some point, don't you?
As well as preserving the aircraft and the vehicles that we work on, we're trying to preserve the skills so that we can maintain these objects as they should be maintained.
Now, I can't help but notice Huey Lamb's Mustang sitting over there. In half. What's going on over there?
Right, what's happening with this aircraft? We're going to be suspending it when we refurbish the American Air Museum next year. So on this aircraft, because there is a natural joint in there, we've separated it. We're going to put in a fish plate, reattached to the empennage, so we just have a small loop protruding above the fuselage, and then we can suspend it like that, and it's less intrusive than a lot of systems you'll see.
So what's the biggest project that's come through your hands here?
The biggest project I personally dealt with is the B-52. We had to paint strip that aircraft completely, repair skin panels that had been corroded, left outside, and then repaint it.
That must be the biggest aircraft here, surely?
It is the biggest aircraft we have in our collection. It's 185-foot wingspan. I believe it's about 165 foot long, about 50 foot high. So yes, it was a big, big project.
You have had the chance in your time here to have in your care some of the real gems in the museum's collection. What's your favourite item?
My favourite item, I suppose, really, if I had to push it, would be the engine we have over there from the Baron von Richthofen's triplane. As a child and a young boy at school, I was fascinated by fight races in the First World War. So to actually touch that, handle it, and make decisions on its future is really quite something.
Let me just get this absolutely straight. You're telling me that over there is the Red Baron's engine from his Fokker triplane?
Yeah, from his Fokker DR1 that he was shot down in, yes.
You see, that's why I love this place, Chris. You never know what you're going to find. This is a place, to me, where history is so alive and so tangible, you can reach out and touch it, and you get to do that on a daily basis.
Yes, it's different, and there's so much variety. Any given day, I might be dealing with a First World War fighter, I might be dealing with an SR-71, I might be dealing with Baron von Richthofen's engine. It could be anything, I don't know. Very often, what's going to come across my desk on any given day.
How exciting is that? Well, thank you very much indeed. I can see that there's plenty of work going on here, plenty more still to do before this aircraft is hung from the ceiling. But next time I build an Airfix model, I'll think of you.
By preserving the vintage aircraft and the stories of the aerodrome, Duxford's vital role during World War II will never be forgotten.
As a kid, Duxford was the first airfield I ever visited, and nearly 40 years later, I'm still exploring it. The collections here are second to none. This is a place where the story, not just of British aviation, but of world aviation, is so accessible and so tangible, you can virtually taste it. The Duxford story itself has inspired countless generations, both past and present, and I have absolutely no doubt that it'll continue to do so long into the future.